last video, we talked about factoring when a equals 1. Those are our easier problems. There's two different ways to factor out whenever a does not equal 1. And they take a little bit extra finesse, but honestly, in the end, they're pretty easy. The same thing that we've been doing, I'm going to do two examples this time because there's two different methods for solving these. But afterward, again, we're going to talk about a problem with the GCF because tricky, it still has one. All right, so the first problem that we're going to do is going to be 6x squared, so example 1. And we're going to solve the same equation in the two different methods, so you can compare and contrast and figure out which one you like more. 6x squared plus 17x plus 5. All right, so the first thing that we're going to do is what they call the swing method. We're going to multiply the back times the front. Multiply the back times the front. All right, the reason why we do this is this makes it easier for us to find the multiples that will divide into 30 but add to equal our 17. So instead of our m being here, this number right here is our m. And oh, let me not do the x squared. Sorry. And when it confuses you. Multiples of 30, but can add to give me 17x. All right, so let's start off with, again, multiples of 30. All right, so we're just going to do 10 and 3 and 15 and 2. And you may have already beat me to the punch and already know which one's going to end up being 17. But I'm going to solve it as if I didn't know. 10 plus 3, 13. 15 plus 2 equals 17. Ding, ding, ding. All right, so what we're going to do is we're now going to replace our middle number, 17x. This is going to get replaced by both of these. We're going to replace it with 15x and 2x instead. So 6x squared plus 15x plus 2x plus 5. And it does not matter. I could have put the 2 here and the 15 here. We would still end up with our final answer being the same. So if you did it in reverse, you're totally fine. All right, so let's go ahead and write ourselves a note as to what we did so we can come back and make sense of it. Replace the middle term with the factors. All right, so now that we've replaced it, we're going to put parentheses around the front two numbers. And then parentheses around the back two numbers. Put parentheses around front two numbers and back two numbers. As you can see, my teacher would have been really mad had they looked at my notes back in high school. All right, so we're going to find the GCF. Factor out the GCF, if there is one. And we're going to talk about that in a little bit because if you notice, both of these are prime. There is no GCF. All right, so if we're doing this one, we're going to have 6x squared plus 15x. We both have an x on both of these, and I know that 3 can divide into both. So I'm going to factor out 3x. And inside my parentheses, I have 2x plus 5. Notice anything? Huh? right, because these are both prime numbers, I'm just going to put a positive 1 in the front because both of these at least can be divided by a positive 1. Sometimes you might have a negative sign, and a good way to know if this needs to become a negative is if this is negative as well. So if this was a negative or a positive and we were trying to make it like negative to positive, we'd factor out a negative. Just putting in that note and hopefully not confusing the living daylights out of you. All right, 2x plus 5 is what we have on the inside. I just took the extra plus off. That's the only difference. Notice that these two must be the same. So if we do it right, these parentheses are the same. We're going to rewrite it with the stuff on the outside in the first parenthesis. And then the one where it's the same just goes on the back. Don't write it twice, just once. And then we're done. This method is probably the method that most of your teachers learned with whenever we were in school. The second method of solving this, the same exact equation, is one that I learned while teaching, but honestly, I think it makes more sense to me because it will give you the fractions that it'll cross on the x-axis with. So I'm going to show you the second method. We're going to solve the same exact problem. So we're just going to make this example 2, method 2. All right, and I'm going to put this paper underneath. 6x squared plus 17x plus 5. All right, this method is a little different, but it has some qualities that are the same. So the first thing that we're going to do, just like we did on the other one, is we're going to multiply the front times the back. Again, we're going to list out all of the multiples of 30. And if I were still doing the same thing as the other side, I tried 3 times 10. 10 plus 3 equals 13. That didn't work. 15 times 2. 15 plus 2 equals 17. We found the one that worked. All right, so this one goes back to what we did when we were solving the a equals 1 problems. We're going to rewrite this problem as if it were the a equals 1 problems. We're going to write it as x plus 15, and then we're going to rewrite it as x plus 2. So instead of putting it in the middle of the equation, we've now put these two at the back of the equation. And then what we're going to do from here, write the factors in the parentheses like a equals 1. Next step, though, is a little different. Then divide by whatever a equals. All right, so on this problem, a equaled 6. I'm going to highlight this in orange. Because this equaled 6 in the front, that means I'm going to come over here and I'm going to have to divide both of these by 6. Simplify your fractions first. Then swing the denominator to the front. And I know that it makes sense until I actually do it. So what I'm going to do is I'm going to simplify this one. Because 3 can go into 15 and 6, I'm going to simplify it to x plus 5 over 2. And then what I'm going to do is I'm going to take my denominator, and I'm going to swing it in front of this x. 2x plus 5. Same thing on this one. 2 can be divided into 2 and 6. Again, my denominator 3 is going to get swung to the front. Same exact answer as the previous method. See? Got the same answer, just 2 different methods to get that same exact answer. I'll do the GCF separated just so that way it kind of doesn't take up more time on this video. So I hope that this helps, and I will talk to you later. Bye, guys.